All right, coding session time. Bangalang. Continuing along with our multi-threading. We did a bit of preparation in the last session. That's right, we did some stuff so we can do like 2D indexing, I guess you could say. You know, in this case, we have an array of 3 vec3s, and vec3s are also arrays. Like, I guess I could have done it like this. Well, actually, that's probably not going to work. Let's see what happens. Oh, that does work. Wow. I'm kind of surprised. I thought that my parser would not be able to handle that when I'm declaring a type, but apparently it does. Okay, that's nice. Nice little surprise there. But we managed to get that working. Another thing that we got working was type conversions. So like this, you see we have an I64 here, and we convert it to an F32, a float 32. So that's pretty awesome. I'm just going to cut out this code at the bottom, this thread pool stuff. So now, what I want to do is take this code here, which draws the triangles, and it foolishly draws them every frame, which is not smart. But the purpose is not to be smart, the purpose is to take time. So every frame is drawing all these little tiny triangles, and you know, it's like calculating the positions, I should say, of all the vertices of all these triangles, and it's taking, you know, it can do it at 300 times a second. There's our FPS counter. So now we want to distribute this workload across multiple threads and hopefully do it faster. That would be nice. So I think kind of the first step is I'm just going to split it out into its own procedure. So if we do a procedure that takes in a slice of floats and an I64, which is the start index. We'll see why that matters later on. And let's take all of this and throw it in here. And then here we'll call task func with our buffer data, and we'll just pass it as 0. So, yeah, okay, so there's a couple of things we're going to need to do here to get this to work at all. First, I'm going to change all these to be data, and yeah, another thing we're going to do is we're basically going to change how this loop works. Because the idea of the start is that we're gonna take our buffer data. Okay, maybe maybe it's a bit easier to explain if I start from the beginning. This returns a pointer to float 32s. I'm going to make that just an I8, so it's kind of consistent with everything else. And we're going to call this buffer data raw now. So that's just a pointer to an I8. And then what we're going to do is go buffer data I64, and we're going to make that an array of 2 I64s. And bear with me here. And then we're going to assign into it a couple of values. And then we're going to create a vec3 slice. Okay, so vec3 we have not yet defined. It was in that code that I took out before. So let's go vec3 equals f32.3. It's like a type alias there. So, and we want a slice of them. Now remember, a slice is a data structure which is a pointer to some data followed by the length of that data. And both of those elements are I64s. So this buffer data I64 thing with two I64s can be a pointer and a length, which we then, using this hacky untyped thing, kind of convert to it. Like we take that data and we copy it to here, and then we say, hey, actually this is a slice. So the length is the number of vertices, because there's one vec3 per vertex. And the vec3 contains 3 floats, which is the x, y, and z. So I'm actually going to maybe make a vertex count, which is triangle count times 3. We don't need to provide the type because it can be inferred from this. Vertex type. So vertex count can go like that. And then I think also we use down here. Yeah, instead of multiplying that by 3, we can go vertex count. And this vertex count is the length. That's the number of vec3s that we have in this buffer data. And if we put this here and we say, hey, this is untyped, so we're taking the pointer to this, this buffer that's on our GPU, and we're saying, yep, use that pointer as our data. The length is the amount of vertices, and we're going to interpret this structure as a slice of vec3s. I hope that kind of makes sense. In the end, basically what we have, yeah, is a slice of vec3s stored on the GPU. In the future, I'm going to make this a lot better. I would like it that we could do something like, basically like this. You know, just have like a literal, and then like, hey, we'll construct a slice from these two elements. But at the moment, we can't do anything like that, so we do this hacky thing. So now this buffer data, as it gets passed into here, it's expecting a slice of vec3s. And the start index is like, where in this full list are we starting from? We won't worry about that right now. We're just going to put 0 here. Actually, maybe I'll just cut this out for now so it doesn't confuse things. We'll bring it back in later. So now I want to say for index, which is an I64, and index is less than, and we're going to have to introduce a new feature here. I want to be able to do dot length on slices. This at the moment is going to throw an error, but I want that to be valid. So we're going to have to implement that and increment the index. And this is what we have in our loop. We're going to need a triangle size. I guess where did we figure out the triangle size? This is where we did it. And that's the only reason we use that. So maybe I'll just put these here instead. I think that's okay. So now we have the triangle size. So now here, I need to figure out a few things. I need to figure out which triangle I'm looking at. Triangle index, which will be index divided by 3. This is integer division. So basically that'll tell us which triangle we're in. And which vertex are we looking at? And that will be mod 3. So that should tell us which vertex within the triangle we're looking at. Okay. And we're going to need to figure out x and y. Let's figure them out in a minute. So this is going to loop for every vertex that we need to draw. We're going to go through this loop. And then we're going to do this kind of thing. So let me cut that out now. This kind of thing. So data index and we don't need to maintain this float index anymore. That's essentially what our loop is doing. So we end up here, but this is all 3 vertices. And that's why we have this vertex index here. So we can say like, if we're looking at the first index, the first vertex of the triangle, so that'd be vertex equals 0, then we do this. If we're looking at the second vertex, then we do this. And if we're looking at the third vertex, then we do this. Yeah, that's basically it. But now we need to figure out x and y. So they start at -1. I kind of cut out that loop now, didn't I? So, and each time we increment by triangle size. So it's kind of like triangle size times, I guess the x would be multiplied by the number of columns that we've got to. So let me have another look at this loop and see. So in this loop, y is the inner loop and y is the row. That's the row. So to increment the row, we just increment by 1. And I guess this triangle count 1D is like the number of rows. It's the number of rows or the number of columns. So then I guess it's like triangle count 1D. Maybe just to make it a bit more clear, we can say like row count equals and column count equals. So that'd be like triangle count 1D would be like index divided by the number of columns. Index divided by the number of columns. That'd be the x value. Index divided by the number of columns. So this y gets incremented every time. So that's like coming down every time. So that's the row. That's the row. So I think we're talking about mod here. I think it's the same kind of thing we did before, but it's like this one's divided by, that gives us the column, that gives us the row. So x would be the row count. No, column count. And that'd be the row count. Geez, I hope this is right. I'm feeling a little bit sketchy about this, but this might work. I guess we'll find out. We're just going to call it here. So the difference with this loop is it's kind of independent of where we start. We could start halfway through this array and it would still just work. That's kind of the idea. What happens when I run this? Line 82. Line 82, column 32. I thought this was kind of, see, this is the annoying error message thing that I thought I had fixed. Is it in parsing? We do parse, yeah, parse assignment or right-hand side expression. I thought this should have solved it. I might just flip this. But I mean, that shouldn't really make a difference. I feel like we should be getting a better error message. Oh, well, it's totally wrong. I mean, the error message was still not good, but see, now we get length is not defined. Okay, so that's fair. So we need to implement that dot length. Let's try that out. I forgot to set a timer, so I might have to just switch to this every now and then just to check my time. Well, I know it's 16 minutes now, so I'll start a timer now. Just in my head, I'll add 16 minutes. So, right, we need dot length. So I think like our parsing and everything is all good. It's just like type checking. We need to be able to say like, we need a way of saying dot length is okay. So I guess it would be in our identifier. So is struct member. It kind of is a member, but not a struct member. So let's just call that is member. And maybe what we can do is say like, if child type node dot value is, if we're dealing with a struct, then we do what we did before. Although one thing I want to add here that we don't have checking at the moment, which we should be checking, is whether it was a valid member. And then we should have some error handling. So like is not a member. That should do the trick. Yeah, that's good enough for now. Some checking. So, but if it's not a struct, then we can say if the member name, which I guess is this, if it's length, then is that just all good? Can we just do length on anything? Do I need to do any extra checks? It's a bit weird, but like at the moment you can index into just anything. Like this is just an I64, but I could go, I'm pretty sure I could say like that. It's probably just going to complain about the length. Yeah. So I think this is valid because this is just a single value, so I can index it. If I did this, it'd probably say it's out of bounds. Yeah, index 1 is out of bounds. So it's a bit weird, but you can do that. So I guess technically you could also do this, and it would just be a length of 1. And I think that's fine. So maybe I'll just say if it's not length, like length is valid for non-struct things. But if it's not a struct, then I guess it must be like an array or a slice. It's not a reference because we just auto-dereferenced. Or it could be like some scalar, which we're saying is okay. I think this is okay. I think this is okay. I'll just give the same. I'm not sure what to say here. I'm just going to say the same thing at the moment. That feels a bit weird. But so this should allow me to always just say, hey, what's the length of something? Put dot length. And then in generation, obviously, we need to actually do something with that. So if we go down to the identifier stuff here, then again, we need to say like, hey, if this is a struct. Oh, so that's interesting. So then a struct, you couldn't do dot length on a struct. But you could just do it on an i64. It's a bit of a weird, yeah, it's a bit weird. I mean, yeah, and I think we kind of have to do it like that because you could have a struct member, which is called length. I think eventually we're going to take away this ability. Like you shouldn't be able to do dot length. You shouldn't be able to index just on a scalar value. I think we're going to get rid of that at some point. Okay, so if we're dealing with a struct, we do what we did before. Whoops. With our member stuff. Otherwise, if we're talking about the length, then what do we need to do? Well, I think we already do have some code. I think I jumped a bit far away. In here, I think this is it here, link location. So this, depending on whether you've got an array or a slice or neither, this will get the length of something. So see, the length of something that's not an array or a slice is just 1. So I think I'm going to grab this and extract it so we can use it in multiple places. I'm just going to throw it at the bottom. So what is it, like get length location. And what do we need actually? Is it a type node? Is that all we need? Oh, it's a child location. But this is also a child type node. So maybe we can just say AST node and location. And then I feel like this is going to be like the container location. The container, like I'm saying container, it's like the thing we're trying to get the length of. And the container type node feels a bit weird to me, but I think that's okay. So we just do like that. And I guess actually we could do like this and then just have some returns here, like that. So if it's an array, we can just grab it from here. If it's a slice, then it's part of the slice object. Otherwise, it's just a 1. Okay, I think that's okay. So now let's substitute that in here. So length location is get length location with the child type node and the child location. And then I should be able to go back over here and say, I want, is it still like the child stuff? I mean, I guess so. And then I guess that would become the length location. I think I want to make sure that this always returns. That's what I was just going up and down a bit. Like, if I come into this is member, I think I always want to return. I mean, if it's not one of these cases, Well, okay. So let's just put a, do we have any of these kind of, I just want like an assert here. Like this should never happen. Should always go into one of these. Then maybe I can just do like this. So I'm either returning or I'm like failing. So this, I guess, could go into here. So we just want, if we're getting the length, then we want the length location. That makes total sense, right? And this is like failed to generate, what are we generating here? Primary. That'll do. So I think that should mean that the length thing works. Length is not defined, 87. 87 now. Oh, we must have just added some lines or something. Oh no, we had an error here before, that's why it said 82. So it's still saying length is not defined. So where do we get is not defined here? Well, doesn't it, isn't it a member? I feel like it should come back true for member. Let's check this as member. Is this, it's specifically getting structs. So I think we don't need to do this, and we might just kind of recurse. So we might just say like, is member. So if we find a reference, then we just recurse, I think. So we just go, yeah, we just get this guy. And otherwise we want to find another identifier. Yeah, I think we need to check, like, is this guy an identifier? Is the child an identifier? Also, actually, we need to check here. Is the first child a reference? If so, then check is member of that. Or, well, I guess it's check is member of. So if it's a reference should always have a child, right? Can we assume that at this point when we're checking as member? I think we can, because it should be well structured at this point. And no, but we're always looking at the child. Maybe this recursion, I think it's not really going to work so well. So if the child is a reference, then let's just check that the child of the child is an identifier. Otherwise, we need to check just that the child is an identifier. Maybe that's enough. Let's see. Let's see what happens. Line 95, we have an issue with type conversion. Column count should be Yeah, that's right. So that needs to be converted. This here is where we needed, this is why we needed the conversion stuff, right? Because we're calculating this value using I64s, and then we need to use the calculated value in an F32 calculation. So really we need type conversion at that point. This is totally correct because we need to set the first, second, and third values within the vec3s. I've forgotten about that part. Now we get a segmentation fault. So let's see what our issue is. Probably it's null. Yeah. So we don't have a type node. So what is our node? Length. The length node doesn't have a type. Of course. That makes total sense, actually. So in type checking, when we come across this length node, so this is the length node, we've identified that it's a member, and it's, so maybe we do something like this, invert this condition, and then we say like, hey, this should be an I64. Right? So we give it a type. I think that's the problem, is that it didn't have a type. It is totally not happy. Probably don't need to do that. Okay, operation size not specified. 1453. Interesting. We are dividing by memory location, and the divide operation is like, hey, I don't know how big this is. I think that's what it's trying to say. Operation size not specified. So let's fix up our divide, shall we? That would be in generation. It would be up a bit further. Here we go, divide. So here's our divide. We need the operation size. This is like the only place, I think. So let's just go operation size. Do we have the byte sizes anywhere? Probably not. No, we have the type nodes. So it's like a byte size of the, I guess we're using result type everywhere here, so we'll just use result type. Oh, I think this needs the context as well. And while we're at it, this right-hand side copy has a bit of an issue because it's a right-hand side. So when I do them with left-hand side, I use register num. When I do right-hand side, I use register num +1 to prevent conflicts. So that needs to be +1. It's a little issue. So what's wrong? Okay, there's nothing wrong with that. So hopefully that should fix up that divide. But we still have more issues now. We made things worse because that's what we do. Yeah, so that's no good. And why is that? Oh, because we need to actually give it somewhere to put that thing. Okay. We have a very high frame rate, but we're also not drawing anything. But we're doing this every frame. Why would we not be drawing anything? Is this data.length not have the right thing? Let's, that's kind of, I think we can do like print b line. Go like that. I think we can, yeah, we can do like print b line and then let's put data.length in here. See what that comes out with. Should be a nice big number. Yeah, I think that's the correct number. So it's going through the loop the correct amount of times from what I can tell. So vertex index should always be 0, 1, or 2. It seems suspiciously always 0. Index divided by 3 is always 0. Really? What is index? Index is always 0? I thought we established that data.length is a big number. So it's 0, big number, increment. I'm not like returning early or something? Like what's... no, yeah. While index is less than data.length, that's right. In a previous session, I managed to get this around the wrong way somehow. So let's just, let's print this out again. I just want to be like doubly sure that it's a big number. And it is. Like when index is 0, vertex index should be 0. That's correct. But then index should increment. And I'm a bit confused about why that's not happening. Why would that not happen? I'm doing it right here. So the only explanation I can think of is that we're only doing this loop once. But 0 is less than a massive number. So why would we only do it once? Why would index always be 0? This is very strange. This is very strange. There was an issue that when I was playing around, I do a lot of playing around, by the way. I don't just like jump in and just like manage to magically do all, like it be as productive as I am. It's because I'm playing around a lot in between these videos. I'm not that good that I can just like get through this project as quickly as I do in the videos. Where did I see this issue? It was in... this is a call. It was up here. Not in the identifier, but in the index stuff. There is an issue here. So this is where we're indexing into something, and we want to find the address of the memory that we're indexing into and basically offset it. Now, if we're indexing into an array, the address of the data in the array is, like this child location, is the address of the array. well, this child location is the array data. So then by doing a reference, doing a load effective address, this then will contain the address of this data. But if it's a slice that we're indexing into, it's a little bit different because the slice itself consists of a pointer and then a length. So if you have, so this child location is the slice data, which means that it is a pointer to the data because that's the first thing in the slice. That probably sounded a bit confusing, but basically if we're indexing into a slice, what that means is that, so this location here is the location of the slice. We don't need to get the address of this data because the first thing in this data is the address. So all we have to do, so we just want to copy that. We just want to say, I want that data. So address location now holds that data. I think that's the idea. See, here we go. So now we're getting somewhere. Okay, so that, I think that was our issue. So we're getting somewhere. It did not look like pretty triangles. Let's cut out this output now because I think it's causing issues. Yeah, so it doesn't look like pretty triangles, so, but I think maybe this is our math in here. It could be wrong. Yeah, this kind of stuff. So the triangle index is the index divided by 3. That feels right. Where do I use this triangle index? Where do I use this triangle index? Should that be there? Yeah, not the vert. Yeah, I think so. Is that right? Hey, there we go. Lots of tiny triangles. Okay. I'm happy with that. So we have lots of tiny triangles, and it looks like our frame rate has maybe gone down a bit, which kind of makes sense because we're like redoing these calculations a lot, where before I think we could have optimized it a bit. See, for every vertex, we're doing all this calculation, whereas in the old version, for every vertex, we can do a lot less. So we just do this increment for every vertex, and then every time we come to a new column, we do this increment. So per vertex, there was a lot less calculation going on. So this is actually slower. But the reason we extracted this out into this function is because I want to do some fancy stuff. I think this stuff, oh, we still have I8 cast here. This is like the old way of casting. Should be able to just do this now. And while I'm at it, there were actually, I'm going to put this down the bottom, because that was up there because we couldn't do out of order procedure calls, and now we can. Thanks to the previous session, we fixed that up. Oh, we do have this already. I was about to say we need to add this, but it looks like we already did. So that's good. Can handle negative numbers. All right. Where were we? So we have this thread pool stuff. And now I want to create a procedure called boomstick. Now boomstick is going to take a thread pool. It's going to take a kernel, which is a procedure that takes, you know, it's kind of like this procedure here. So it takes a slice of vec3s. So I don't actually want vec3 to be in the standard library, but I'm going to put it here. For now, I mean, like I'm making this boomstick thing, which ideally I want it to be like a generic thing. Let's figure out what the boomstick actually is first before I start trying to explain more things about it. So we want this kernel, which is this procedure, which needs a start now. We're going to add that start. Then we're going to provide the data. Is that all we need to provide? I think it is. And then essentially, we're going to slice up this data, give it to this kernel on different threads. That's the idea. So if we go worker data length equals the length of the data we give in divided by the worker count, right? And then we say, you know, for each worker, so for each worker, whoops, we basically want to create a new task and enqueue it. So that means we go task, which is a thread pool task, where the function is the kernel. The data is this data, but we're going to slice it up. Let's get to that in a second. I think that's all. Yeah. So we're going to have to, I really do want to make this more like generic and better at some point, because we're going to need to pass in this. We're going to need to have this stuff in here, but for a generic thread pool, I don't. See, this is very specific, what we're passing in to this thread pool. So I do want to get more generic. That's something we'll need to get to fairly soon. So now the task.start can be the start, which is, what is it? Good question. And then we're going to enqueue the task in the poo, in the pool. So we need to know those numbers. So these are like the start equals end equals, and end up like that. And start would be index times how many are in each worker, and end, I guess, would be start plus how much are in each worker. I think that's correct. So that should slice up our data and give it to different tasks and enqueue that in our thread pool. I think that's about it. So then, oops, when we go back here, we can go start. We need to give this a start now. So this is why we have a start here. So when we slice up the data and give it to our thread pool, at least in this case, we need to know how far into the data did we start, because we're using this index to tell like which triangle, which vertex we're in. But that only makes sense if we know the overall index. This index here is only into our slice of the data. So we need to know where did that slice start. So it's like start plus index is our overall index into the full list of data. I think that's the only place we need to use it. Yeah. So then if I put a 0 here, it should still work. Ew. Well, that's not a very nice error message. Not very nice at all. I think this should be, what did I call it? File error. Okay, at least we have a better error now. So standard library 152, that's here. What's wrong with that? Invalid token, line 40, column 47. Oh, I used a semicolon out of habit. Most languages you use a semicolon, but I use commas. There are no semicolons in my language. Nowhere. They are not allowed in anything. Okay, so line 122, wrong number of parameters. That's probably because I've added this start business. Yeah, that's here. So then we need to pass along the start. When we're running tasks in our thread pool. Let's try that again. Data is not defined. Line 150. I think you'll find it's defined right here. Right? It's defined right here. Why would you say it's not defined? We also get the segmentation fault. So let's auto dereference. So we're trying to auto dereference a child node. Which is data. And what was the error that we got printed out? Data is not defined. It's not defined. Yeah, so that would make sense actually that we would, because data didn't get processed. But if that returns false, so we should have like we should have an all return there. That would prevent, yeah, that prevented us from getting the segmentation fault. Because if there's an error in here, we shouldn't try to keep parsing. So data is not defined. Data is not defined, so couldn't find it in the identifiers. That's interesting, because to me it's right here. We have pool, we have kernel, which is a proc, we have data, data.length. Yeah, this is one part of my language that I'm not sure about, because this is valid. This is declaring a variable with this type, and then this is a separate thing. It's just a scope. Just a scope with some code in it. And then when I go equals, that combines them together. It says, okay, I'm declaring a procedure of this type, and here's the body of it. You know, I'm assigning the body of it to it. So that's something in my language that I'm kind of not so keen on, because if you accidentally did this, especially coming from another language where this is probably like more close to the regular syntax, you'd probably be like, hey, what's wrong? Like, this looks fine. It might not be so obvious that you need to do this. Okay, incompatible types, I64, I32 at line 150. So the worker count is an I32. Okay. Well, let's just convert it. I mean, where do we use it actually? We use it in some loops where it's I32. Well, here it's I64. Let's change it to an I64. And then just anywhere where we loop, we can make that an I64 loop. Maybe that'll work. Procedure types. I would like to make this output a bit better, so it actually shows the proper procedure type. But I'm kind of feeling we don't really have enough time right now. But it's saying this kernel of this type, datavic3 start I64, is not what this func is expecting. I thought I changed it so that it was expecting that. It's vic3, right? Vic3? Yeah, vic3. So actually I need to declare this like way up here. So that also needs to be vic3. Okay, unsupported precision. Generate conversion call. The return type is I8. So it has a byte size of 1, which you can't get a precision of. That makes sense. I think this really needs to just be inline. Because yeah, for a lot of integer types, this is just not going to work. Parameter precision. That's what you get for doing really half-assed testing. Okay, now we have a bunch of triangles, and the frame rate is kind of what it was before. Maybe even slightly lower again. Oh, well, I didn't actually change. Yeah, we're still just calling it directly. So now the moment of truth. We've adapted our thread pool. We've created this boomstick thing, which should like distribute things across threads. To start with, just to keep it simple, let's create a thread pool. And have a worker count of 1. Is there anything else we need to initialize in a thread pool? No. We'll give it a worker count of 1. And so then instead of calling this directly, we're going to boomstick it. Boomstick with a pointer to the pool. We pass in the task function and the buffer data, and they should divide it up across one thread. Another thing I want to do, though, to prevent it from because it's going to do this, but it's going to do it asynchronously, so this loop is just going to keep going. So I want to this is going to kick it off on another thread or multiple threads, but then I want to wait for it to finish before I continue this loop, this idea. So I'm going to do a thread pool wait, and this is going to be a terrible thread pool wait. One thing I'm already not happy with and I want to fix up is the semaphore wait, because it just spins, right? It's just using up CPU time to do this. And there's better ways to do it so that it doesn't use up CPU time. This thing that I'm going to implement here is also going to use CPU time and be terrible, but we'll fix it up later. So I'll just put a comment there that we're spinning. So if there's no tasks and I'm going to create a current worker count. So if there's no tasks and no workers running, and unfortunately we have to return something, we can't just return, I'm going to return true. Otherwise we're just going to keep spinning. These two things need to be 0. I can't do ands or ors yet. It's another thing we need to implement. So instead we're just going to have 2 nested ifs. So now we need this current worker count. Let's put that here. We'll start with 0, and then I guess we increment it when we're like preparing to do some work. And then when we're done, we decrement it again. So the idea being that we should always have, if there's something left to do in the thread pool, then we should have at least one task waiting or at least one task running. That's the idea. I'm checking for that. And if neither of those are true, that means we've got nothing left to do in the thread pool, and that's where we can just continue. So let's see what happens if I run this. It's not looking good. We don't even get our frame counter. We just have a thread. We just have a thread pool with one worker. Oh, it would probably help if I started the thread pool. If you don't start the thread pool, it's not going to do anything. Okay, but that didn't actually help. Not really. Okay, so let's have a look at what's going on here. Oh, that's right, we can't control click. So we're going into Boomstick. For each worker, we're dividing up the work. Let's try. We only have one worker, so it should effectively be all the data. We are in queuing. That did not help. But does this make sense? Worker data length is the length divided by the amount of workers. Index times that is the start, and the end is that. Worker thread pool in queue, so we kick it off. Like, it all looks right to me. And this is our function. So I'm pretty sure that function works on its own, right? Ooh. Oh yeah. It even takes a lot to like cancel this thing. Why is it not? Okay, let's quit that out. Let's get rid of this window as well. Sometimes they stay open for a bit. I hope I'm still recording and that things didn't get too screwed up just then. But if we go to task func, I actually don't see what the issue would be there. I'm going to temp fade and run it again. Look, it really freezes things up. But what did I add? Like, if I take away this... Just by starting a thread pool with one worker, it causes issues? What did we change in there? We changed these loops, made them -64, but that should not be an issue. Like, the index is not actually used for anything. We added the thread pool wait, but we're not using it right now, right? Yeah, we commented it out. We changed this, so we increment the current worker count, and then we decrement it here. We lock and unlock. That should be fine. I mean, what happens if I take this stuff out? current work account. That does exist, right? I'm worried this is going to be messing with my recording. But it's really, something has really messed it up. Hey, something with this thread pool. Thread pool start. Start thread. I haven't changed anything with that. Should be a pointer to a pool that we put in there. So if I take away thread pool start, I get a whole bunch of triangles. And when I put thread pool start in, it's just like, it freaks out. That's still freaked out. Why would that? I am getting the feeling there's like some sort of corruption going on here. Because this behavior is really strange. Because thread pool start is just doing a basic little loop. You know, if I make thread pool start just an empty procedure, okay, now we're fine. But if I make it this loop, is it an infinite loop? Like, is work account somehow negative? I mean, I'm setting it to 1 right here. Let's print it out and see what it says. 1. And my I to A handles negative numbers. It should put a minus there, which it did not. So in my thread pool start, are we in an infinite loop? Let's try that. What the hell? Why is index such a massive number? It should be getting initialized to 0 implicitly. We shouldn't need to do it explicitly. I don't know if we can do it explicitly. Is that valid? I guess so. I still think it's a big number. Like if I go back to that and then we go thread pool start and we have a look in our assembly, and we're looking at the for loop. This is initial assignment. So that should be this here. See, so it's like it's doing a nil assign. So it's setting it all to 0, 8 bytes of 0. And here's the for loop condition. It's getting RSP plus 16, putting it R12. So RSP plus 16 should be not this. It should be the last parameter, pool. So it should be the first thing in the thread pool, which makes sense. The first thing in the thread pool is the work account. So I think that's right. Then it puts in R11, it puts this guy basically, so 0. And then it compares it to this. So now I'm confused, like why did it bother putting it in R12 if it's just going to... What is this about? What is this about? So it is a pointer. It is a pointer. So it should be using, it should be dereferencing it, it should be using that in this compare. What the hell? R12, there should be, it should be like this. So the comparison is messed up. Okay. So, and this is for a for loop. This is the for loop comparison. So let's go to our generation. This is super weird. Like we haven't had any trouble with for loops for a long time. I'm really surprised this is cropped up. Hopefully it doesn't spill us out too long. So when we generate our for loop, we generate our expression. We have an expression destination. And that destination is what we test. This is our compare, test expression. So if we go back to assembly, test expression, that's our result less than. Okay, so our expression in this case is index less than pool.work account. Yeah, so we have a less than, this is our index going into R11. So it's like our dereference is not returning the correct thing. Wow, this is so weird. So it's generate expression, generate primary. So it's dereference here. So it should copy to a register, right? Should copy to a register and return that register as memory. Let's go to assembly. So it copies to a register and it should return that register as memory, which is what I would expect to show up here. You know, if it's on the right-hand side. So if that returns up to here, returns up to here as the right-hand side. And then I think we would go into, well, it's not, the operand's not pool. The operand is the I64s. Both of them are I64s. Right. So we would go into here, signed integer, and we would do the comparison, right? We would go into compare. Left-hand side gets copied into a register, right-hand side is just whatever we got, whatever came in. Sorry, I'm getting a little bit lost in my files. So why does the right-hand side that comes in, why is it still this? That's the part I'm really confused by. left-hand side, right-hand side is the return value of this. We should have gone into primary, should have gone to dereference. Which takes the thing that we were dereferencing, which should have been a reference, right? If we're dereferencing, then there should have been a reference. Yeah, because pool is a reference. So actually, there's also not an index, there's this identifier going on. So the child location, so it comes in and does the dereference as the child, and then we come along here and we go, okay, we've got a child of a dereferenced thing, so it should be a memory address of that register, and then we come in here and we say, like, was it a member? Is this one a member? Yes, it is. So we take that child location and we offset it and return it. We take this and we offset it to get to here and we return that. And I'm so confused about why that's a problem. Like, why this is so weird. Why are we getting that? It's totally wrong. Totally wrong. I think if I go into main and we've disabled our tests. Let's leave them disabled just for now. I keep forgetting to re-enable them. If we do a build and we just like skip out the compile step, so we just run, so then we can just like modify this and it won't get overwritten. So if I do that, it works, right? Then it works. Thread pull start is fine. It's not causing any issues. Where's thread pull start? Yeah, and it just prints out an index once. That's it, done. Okay. So that is the issue, that should be R12 in there. But why the hell is it not R12? That's the part that I'm just like, what the hell is going on here? Because it's a reference to a struct. Okay. So maybe we need to do this. Dot value is like not right. So we probably should do it in here as well. Because it's a reference. Was that it? So if I go back into main, I re-enable compilation, I still get this madness. So that was not it. Yeah, because I think here, because we do this auto dereference, the type node should be directly a struct. It shouldn't be anything where we need to, like, usually we need to use this if it's like a reference to something, so we need to like drill down, but we shouldn't need to do that in this case. Console.log, nearly did console.log. So we should do like print, maybe not a print line, let's just do a debug here and see if we can get our guy. So we're talking about work account equals 1, great, We're doing that. So where is it that we're actually caring about? It's pull.work account in this loop. Oh. It didn't go in there, did it? Maybe our is member is dodgy. I would not be surprised if this was dodgy. So where was it? Here. Go to type checking. I'm going to is member. And get our identifier. We have like the semaphore, mutex, task count, mutex, task count. So these are all thread pool things. But they're all thread pool things where we're not dealing with, like there's no reference node in between here. It's just identifier. So I think these are things, so there's like unlock mutex. I think this is in the worker here. But this is a reference. So shouldn't there be a reference node in there? There's a reference node there. Something fishy is going on here. I feel like this is in the wrong structure. I feel like the reference should be in the middle here. Okay, so yeah, so this is an identifier of type pool. And that identifier is a reference to a struct. Yeah, okay. That makes total sense. That makes total sense. Okay. Here's pool.work account. This is I think this is the loop. Yeah, we're printing out the index. Yeah, this is the loop. So we have an identifier of work account whose child is pool, whose child is a reference to a type. So it does go into here. And then it should go into here. It does. And then in generation, we should also, so this is work account equals, that's where we're setting up the work account. But in generation, it doesn't go in. Why would it not go in generation? What changes about this structure? Well, we do the auto dereference. We do the auto dereference. So there's a dereference node in there. Yeah, so we could have a child which is a dereference or an auto dereference. So I think we need to do a bit of a loop, actually. This is what I think we need to do. So yeah, I think we need to do that, and then we need to say like node equals this guy. Cannot assign a parameter, so I'm just going to say final node. I'm going to try and be quick because we're already going quite long on this video. So starts off as node, and then we keep making it the child as long as we come across dereference and reference. Then we keep making it a child, and eventually we should find that its first child is an identifier. Let's try that. That's not promising. Oh, did I make an infinite loop in there? I think I did make an infinite loop. I think I know exactly why. Because this should be final node. That should be final node also. There we go. Jesus, okay. All right, so that procedure was all messed up and causing an infinite loop. So now that we've fixed that up, we can actually start our thread pool. We can uncomment that stuff. Was there anything else that we commented out? I don't think so. So all the standard lib stuff looks fine. Go back into here. Let's try just running it like that. Okay, we're still on our single threaded business. Let's try transferring over to our boomstick. Okay, and we still get triangles. Great, and the FPS is pretty similar, which makes sense because we're only going across one thread. Let's try 2 threads. Okay, and our FPS is higher, not double, but higher. Let's try 4 threads. So we were starting, like in the beginning, I think we were around 200 FPS. Now we're up, yeah, we can get up to 500. Let's try 8 threads. I don't think I'm going to try past 8, but let's try 8. So that didn't actually get us that much more than 4, which is interesting. I think it could be because of our spins. We have some aspects of our thread pool and stuff which are using up CPU that shouldn't be. But we can see at least that we're getting more FPS by using the boomstick as opposed to just a single threaded solution. Now, we are, it looks like almost an hour and a half in, but I'm pretty happy we got this working. And something I wanted to explain like really near the start, and then I sort of gave up on it, and I want to come back to, is so this boomstick and our thread pool is very specific now. It's not very generic at all. It expects one array of vec3s. That's all it's going to work on, which is not great. In some cases, we might want to pass in like multiple arrays of data. The data maybe is not vec3s. Maybe it's something else we want to work on. You know, there's all these different ways that we might want to use boomstick. And to get into that, we're going to need to get into some fancy stuff. We kind of, to really make this generic, we can either have like some special handling for boomstick, or definitely one thing I want to do is be able to do like this. So it's kind of like an anonymous type. And then whenever you call boomstick, it should say, okay, substitute in the types correctly. So go like this, actually. So it should substitute in the types correctly and generate a variation of this procedure for that type. And it would need to do that for every type, every different type that you called boomstick with. You know, it's kind of like, that's kind of like what templating does in C++, that kind of thing. And that's how we would have, I guess, you could call it generic sort. In Odin, this is the syntax they use in Odin. That's where I'm stealing it from. I think in Odin they call it like parametric polymorphism, which sounds very fancy, but yeah, same kind of idea. So that's one thing. And then you'd also probably want like variadic parameters, because you'd want to be able to have variable numbers of parameters that you pass into Boomstick. So that's getting pretty advanced. I don't even know how to approach that. But those could be very handy to getting like a real Boomstick working. And then eventually I want to be able to go Boomstick at GPU. That's what I really want to do. And then that should, or it might be that task func we declare as a GPU procedure. I'm not sure exactly how we're going to do it. And then when you pass it into Boomstick, it'll know like, okay, I need to run this on the GPU. Yeah, that's the really big thing that I want to implement in this feature. That's going to be a huge piece of work, but so that I can just take workloads and move them between the CPU and the GPU like super easily. And Boomstick is kind of like the cornerstone of that. So, enough for today. We're over an hour and a half now. Thanks for sticking around if you're still here. Yeah, thanks for stopping by. That's my usual catchphrase that I stole from Anchorman. Have a good one. Ciao for now.